Alright, welcome back guys. Today we're going to continue evaluating trig functions, but instead of looking at the degrees like we did a lot in the last video, like when I asked you things like what's sine of 30, I'm going to flip to radians and we're going to work more with radians on this video. And really, they come up 50-50, so it's really important to know both of them equally as well. This was going to be example 4 from the last video. I just was running out of time and I didn't want to make the video super long. That you watched yesterday. So let's pick up where we left off. This time I'm asking you to evaluate all 6 trig functions. And remember what the 6 are. They are sine, cosine, tangent, and then you write CSC, CSC going down, and then fill that in. So cosecant, secant, and cotangent. So I'm asking you to actually evaluate all 6 of these for negative 120 degrees. And remember, that's easy to do because once you know sine, you know that cosecant is just 1 over sine. It's just the reciprocal. So you're just going to do 1 over your answer. So it'll actually go pretty quick as long as you know which ones are reciprocals. And you know that by writing it in this exact way that I showed you to write it. Okay, so I just spaced it out a little bit so we'd have room to write our answers. So first we need to know is where's negative 120 degrees. So on the unit circle, I know I'm going to start by going backwards. Well, I know that negative 90 degrees would be right here, and that's just 30 degrees more than that. So I know that I'm talking about this spot right here, and that's where negative 120 degrees is. Okay, so as far as the unit circle goes, since that's close to the y-axis, that's going to correlate to all the other ones that are close to the y-axis. So if we draw in all the spots for the unit circle, I'm talking about these yellow ones right here. And what are the coordinates right here in the first quadrant at that spot? That's 1/2 comma square root 3 over 2. So then I know negative 120 degrees, which is the one right here, that would have the exact same coordinate. It's just that both the x and the y's have to be negative. So both of those coordinates have to be negative. Okay, so now that I know that, I can answer these questions really quickly. So what's the sine of negative 120 degrees? Technically, you write it like this. Sine of negative 120 equals, just because literally I'm going to run out of space, I'm not writing it, but that's how you should write it. Okay, so the sine of negative 120, that's just always your y value, so that's negative square root 3 over 2. The cosine of negative 120 is your x value, so that's negative 1/2. Tangent is just you divide the two. So negative square root 3 over 2 divided by negative 1/2. Well, first of all, the negatives are going to cancel, so my answer is going to be positive. And let's simplify this by multiplying by the reciprocal of the denominator. That way I don't have a denominator anymore. And I'm going to get... also, look at those 2's will cancel. So I'm just going to get square root 3 actually as my answer. Okay, and then remember that, I'm going to have to erase some of this, but remember that cosecant is just the reciprocal of sine. That's why I wrote it on the same row, which means that's just going to be 1 over my answer for sine, which was negative square root 3 over 2. Okay, now I could go through and do this algebra, and it's not hard. You just have to get rid of this denominator, so you would multiply by the reciprocal, so you'd multiply both top and bottom by that negative 2 times square root 3. That way all this goes away, and then you could say, oh, 1 times negative 2 over root 3 is just going to be negative 2 over root 3, and now I rationalize the denominator, and blah, blah, blah. Okay, so let me erase that. The reason I kind of rushed through saying that is because remember what we're doing. When we say we're finding cosecant, and we know that's the reciprocal, instead of doing 1 over the original, and you end up getting this answer, remember reciprocal is that you just flip it. So instead of doing that work I just showed you, you could have looked at this, literally just flipped it, and then wrote what I have in blue. And that's the same thing as doing 1 divided by something. 1 over that thing is the exact same thing as just flipping it. And we just saw that with the algebra. The only thing that you might have to go back and do a little bit more work is if there's a square root left in the denominator when you're done. And there was. So I do need to multiply by square root 3 just because I can't leave a root in my denominator. And so that will give me 3 in the bottom and negative 2 times square root 3 in the top. So step 1 is literally just take what you have over here and flip it. And then step 2 is multiply by a root if you need to get one out of the denominator. So my final answer for cosecant of negative 120 is going to be negative 2 root 3 over 3. And now that I know reciprocal is just flipping, I can just do these a lot faster now. So secant, I'm just going to take my answer for cosine, which was negative 1/2, and flip it. So it'd be negative 2 over 1, which is just negative 2, and I'm done. Cotangent, you're just going to flip it. So if tangent is root 3 over 1, then cotangent would be 1 over root 3. There is a root in the denominator, so that's an issue. So I do need to rationalize, and that ends up giving me root 3 over 3. And that is my final answer for cotangent. So I'll erase this and put an arrow and show that that's what I would actually write down. Okay? So once you know, so really the hardest part is knowing where negative 120 degrees is on the unit circle, and that's what I did up here, and we counted that out. And then once you fill out your sine and cosine values, the rest is just algebra, pretty easy to get the other 4. Okay, so pause the screen now if you need to look these over. I'm going to have you guys try this one on your own, doing the exact same thing, but for 210 degrees. So find where that is on the unit circle, and then fill out sine and cosine, and then the other should be easy. And remember, you always want to write it like this: sine, cosine, tangent, and then CSC, and then CSC going down, and fill that in. Okay, and when you hit play, I'm going to have all of these filled out, including the denominators being rationalized and everything. So pause, take your time, rationalize the denominator. When you're ready to check, hit play, and you can look them over. All right, so here's my answers. I will give you plenty of time to look this over. I just want to talk about how I found 210 really quickly. I know 180 is right here, so 210 is just 30 degrees past that. So that's going to be all the spokes that are closest to the x-axis, and so that would correlate with the very first one in your first quadrant right here, which has the coordinates of square root 3 over 2, comma 1/2. And then to find this one here, which is what I wanted, I just had to make both of them negative. So negative square root 3 over 2, comma negative 1/2. Okay, so that's how I knew this was my cosine. That's how I got that answer, and 1/2 was my sine. That's how I got that, or negative 1/2. That's how I got that. Okay, check these over. Notice all of my denominators are rationalized. That's the exact form that you should have it in. And when you're ready to move on, go ahead and hit play. All right, so in these next examples, we're going to do the same types of things, but this time I'm going to ask you in radians. So what is the sine of 4 pi over 3? Well, first, let's find 4 pi over 3. Since that fraction 4/3 is greater than 1, I know it's going to be past 1 pi, so it's a little bit past that. Okay, and it ends up being this one right here. This is 4 pi over 3. Remember, all the ones over 3, so I've highlighted all the ones that end in over 3, are all the ones that are closest to the y-axis. Okay, so what are the coordinates there? Well, it helps me to first figure out the coordinates up here in this first one, and that would be 1/2, comma, square root 3 over 2, and then I can find these ones just by copying it, 1/2, comma, square root 3 over 2. But since that's the third quadrant, remember quadrants go like this, 1, 2, 3, and then 4. Since that's the third quadrant, the x is negative and the y is negative since I went backwards and down to get to that spot. Okay, so if it asked me for cosine of 4 pi over 3, this would be my answer. Since it asked me for sine, this will be my answer. So negative square root 3 over 2, that is my final answer. And we're done. Let's try another one. How about cosecant of 17 pi over 6? So first, let's find where in the world is 17 pi over 6. Well, 12 pi over 6, that fraction 12 divided by 6 is 2, and 2 pi is right here. It's after you go around the circle one whole time. So I know that I've gone around the circle one whole time. I'm at 12 pi over 6, and I need to go an additional 5 more, 5/6 more, I guess you could say. So first, all my ones that end over 6 are right here. They're the ones closest to the x-axis. So if I went all the way around one time, and I'm at 12 pi over 6, I need to go another 5 pi over 6 more to get to 17. So where's 5 pi over 6? Well, if I go all the way around, it's right here. So this is 17 pi over 6 because I went all the way around once, which was 12 pi over 6, and then I did an extra 5. And that got me to right here. So just neatening that up a little bit. All of the ones over 6 are all the ones closest to the x-axis, and I can get the coordinates for this one, which is the one I want, by getting the coordinates for this one over here first. The coordinates for this one is square root 3 over 2 comma 1/2, which means the coordinates for this one are going to be the exact same thing, except for since I had to go backwards in the x direction, then the x coordinate is going to be negative. I still went up to get the y, so that's the 1/2 part's still going to stay positive. Okay, then we just have to figure out what cosecant is. So remember when I write all this out, sine, cosine, tangent, and then I write CSC and then CSC? Cosecant is the reciprocal of sine. So if I know sine, I'll be able to get cosecant really fast. And the sine is always the y value, which is 1/2. Which means, so let me write this, sine is 1/2, so cosecant is going to be the reciprocal, so just flip it, which would equal 2, or 2 over 1. And you're done. Now we wouldn't just want to say cosecant equals 2, you actually want to say cosecant, so CSC of 17 pi over 6 equals 2. You have to fill in a number here, otherwise it doesn't really make sense. So there we go. My final answer is 2 because I just did the reciprocal of the sine value in that spot. Okay, so let's do some more. How about the secant of 11 pi over 4? Okay, that's a pretty big number, so think 8 pi over 4. Well, 8 over 4 is 2, so that's the same thing as 2 pi. So if I go all the way around the circle, so I've done this whole thing, I'm at 2 pi, which is the same thing as 8 pi over 4. And I have to go an extra from 8 pi over 4. You would have to go an extra 3 pi over 4 in order to get to 11 pi over 4. So from here, where's 3 pi over 4? Well, all my ones over 4 are, let me draw these in, are the middle ones. So it's all of these ones right here in blue. And 3 pi over 4 is right here. So I can get the coordinates for that one, for this spot right here, if I get the coordinates for this spot. And that's square root 2 over 2, which means this one's going to be square root 2 over 2 for both of them, except for the x coordinate's going to be negative. Okay, oops, let me write that correctly. The negative is inside the parentheses. Okay, so now that I've located where 11 pi over 4 is, and I have the coordinates for it, I can do secant really quickly. Okay, so what is secant? Well, let's write out sine, cosine, tangent, write my little CSC, CSC. Secant is the reciprocal of cosine. So take cosine, which is your x value, and flip it. So instead of writing negative square root 2 over 2, I'm going to flip it and write negative 2 over root 2. That is my answer. So that is my answer for secant of 11 pi over 4 equals that. But I do need to rationalize the denominator. When I rationalize the denominator, this part is just 2, and the top is negative 2 over root 2. The other cool thing is that those 2's will cancel, so my answer is really just negative square root 2. So now I can erase all this middle stuff and just say my answer for secant of 11 pi over 4 is equal to negative root 2. And you're done. All right, pause that if you need to look that over. These are really good examples that go through the entire process. So definitely pause and rewatch those if that was too fast, if you need to go through it more slowly. I just want to make sure we can get to seeing plenty of examples. So we'll do a few more. Try these couple on your own. So cotangent of 2 pi over 3 and cosine of negative pi over 3. And then pause and hit play when you're ready to check your answers. All right, so for the first one, where is 2 pi over 3 on the unit circle? Well, all of the ones that are over 3 are closest to the y-axis. So it's all of these ones. And I'll fill in the other ones so we see what I'm talking about. So I can get the coordinates for this one right here, which is 2 pi over 3, if I get the coordinates for this one, which is just pi over 3. And the coordinates for that one is going to be 1/2, comma, square root 3 over 2, which means the coordinates for this one, which is really the one that I want, is going to be the exact same thing, except for I have to make the x coordinate negative since I went backwards in the x direction. Okay, and then, so now I have sine and cosine of 2 pi over 3. So let me erase that. I know that this is the cosine and this is the sine, if it had asked me for those. But it didn't. It asked me for cotangent, which means I have to find, well, let me write it out. So we write out sine, cosine, tangent, CSC, CSC. So in order to find cotangent, I first have to find tangent and then flip it. So let's work on finding tangent. So tangent is, remember in the last video, sun over Costa Rica, so sine over cosine, which is the sine is square root 3 over 2, and the cosine's negative 1/2. So let's multiply by the reciprocal to make that denominator go away. So now everything in the bottom is gone. And in the top, look what else cancels, this 2 and this 2. So all I'm left with is negative square root 3. So I know that the tangent is negative square root 3. And you can think about that as being over 1 if that helps you when you go to flip it. Which means cotangent, I just have to take this and flip it. So it'd be 1 over, well, it's still negative, negative 1 over root 3. And I can't leave a root in my denominator, so multiply that out. And the bottom, let's start with the top. The top you would get negative root 3, and the bottom, this part here, would just be 3. So that's my answer for cotangent. How I would actually write that nice and neat is I would say cotangent of 2 pi over 3 equals, I'm still working on cleaning this up, negative root 3 over 3. This is how you would actually write your final answer. All right, pause if you need to look at that, and I'm going to clear the screen and show the answer for cosine of negative pi over 6. So negative pi over 6 on the unit circle, think about, remember when we do negatives, we're going backwards first. And so if I'm starting here, I need to go backwards. So it would actually just be this value right here, going backwards. Remember, all of the ones over 6 are all the ones closest to the x-axis, so it's all of these ones right here. And so I can figure out the coordinates for this one if I figure out the coordinates for this one, which we should know. That's the part we should have memorized as root 3 over 3 comma 1/2. And so that means that this one down here would still have a positive for the x. And I realize I wrote root 3 over 3. That's wrong. It's root 3 over 2. They're all over 2. And then this one here would be a negative 1/2 since I'm going down for the y. All right, and then remember that the x coordinate is cosine and the y is sine. I'm asking for cosine, so you're going to answer this one, and your answer is root 3 over 2, and you are done. Okay, so how about if I ask you one that lands right on the axis? Like, how about if I ask you to do all 6 trig functions for 270 degrees? Well, 270 degrees is right here. Remember, because this is 0, this is 90, this is 180. If you add another 90, you're at 270. Okay, so what are the coordinates there? Well, we know the coordinates would be 0, comma, negative 1, because you've gone right or left by 0, but you've gone down 1. So we know that let's just start writing our answers. We already have some of them. We already know that, so let's write this out. Sine, I'll erase this, cosine, tangent, and then CSC, CSC. So we know that sine is the y value, so that's going to be negative 1, and cosine is the x value, so that's 0. So what's the tangent of that particular spot at 270 degrees? Well, remember that tangent is always sine over cosine. So that would be negative 1 over 0. But remember, we can't ever divide by 0. And so that would be, we would just write our answer as undefined. Since you can't divide by 0 and this one has a 0 in the denominator, then the tangent cannot be defined. Okay, now let's jump right now to cotangent. If I were to flip-flop these, it would be 0 over negative 1, and that is just 0. So you can do 0 over negative 1. 0 divided by anything is just 0. But something divided by 0, that's undefined. Okay, so let's finish the other ones. We need to do cosecant and secant still. So cosecant, you're just going to flip sign. So we're going to do, so think about negative 1 being written as a fraction, like negative 1 over 1. If you flip it, you just get 1 over negative 1, which is still negative 1. So if you flip it, you still get the exact same thing. Secant, if we have 0 in the numerator, so this could be, remember 0 could be literally over anything. You could say 0 over 5 and that's still 0. You could say 0 over 10 and that's still 0. Whatever it is, your answer is still 0. If all of a sudden I flip it and now I have some number over 0, then that would be undefined. Okay, another kind of short way of saying this is cosine. When I said cosine equals 0, 0 is in the numerator. If all of a sudden for secant I'm asking you to flip it, 0 would be in the denominator, which is undefined. So I have two values that are undefined for 270 degrees, secant and tangent. And that's just because 0 is in the denominator for both. And that comes up a lot. Anytime you have something right on one of the axes is the plural way of saying that. So if I ask you to do it for 0 degrees, or for 90, or 180, or 270, or 360, or like I can keep going around and around. Anytime you land right on an axis and you flip things, you're going to get a lot of undefined things. So that's okay. That will come up whenever you're right on an axis, and it's no problem. Okay, so why don't you guys try it? See if you can get the ones that are undefined. Those are just be the ones that have you divide by 0. And I want you to do it for 180 degrees, which is right here. So the coordinates for that is negative 1 comma 0. So that should get you started doing sine and cosine. All right, so the sine is the y value, so that's 0. Cosine is the x value, that's negative 1. If I start, let me do cosecant now. If I take my answer of 0, which was in the numerator, and now flip it, and now 0 is in the denominator, that would be undefined. For negative 1, if you flip it, and you have 1 over negative 1, that's still just negative 1. Okay, and then tangent is sine over cosine. So sine over cosine, the 0 is in the numerator, so we're good. So that answer is 0. But that tells me that if I flip it, then 0 would be in the denominator for cotangent, so then this one would be undefined. Okay, I like these ones actually. I love the ones that ask me to do it right on an axis because I feel like you can whip through the numbers pretty easy since all you're dealing with is 1s and 0s. Okay, so let's do some more. You can pause it and try on your own and check, or you can keep playing. I'm going to just walk you through them just for the heck of it. So cosecant of negative 90 degrees. So negative 90 degrees, we would go backwards, so that would be right here. And my coordinates there is 0, comma, negative 1. So if I were to fill out, I know it's just asking me for cosecant, but it helps me to kind of write all of these out just to make sure I get the right one in the right spot. And so it's asking me for cosecant, which is right here. So that's the reciprocal of sine. So let's first find sine. Sine is the y value, which is negative 1. The reciprocal of negative 1 is still negative 1. So my answer, the way I would actually write this, is I would say cosecant of negative 90 degrees equals negative 1. That's how you would actually write your answer. Okay, and let's pause the screen because I'm going to clear the page, so if you need to look it over, go ahead and pause. And let's do tangent of pi. So where is pi? Well, pi is right here. So what are the coordinates there? That would be negative 1, comma 0. So that tells me I already know cosine is negative 1 and sine is 0. But let's fill out my chart in that order that I always have us write it in. So sine, cosine, tangent. I'll go ahead and say of pi, of pi, of pi. So that one's kind of quick to write. And I could do like the CSC stuff, but it's asking me for tangent, so I'm not even going to worry about writing those other ones. Tangent is sine divided by cosine, so I do want to make sure I have sine and cosine filled out. Sine is the y value, that's 0. Cosine is the x value, that's negative 1. If you do sine over cosine, since that's what tangent is, and I'll write it at the top, remember tangent is always sine divided by cosine. So I'm doing 0 divided by negative 1 over here because I'm just plugging it into that formula. And remember, 0 is okay if it's on the numerator. So that's just going to be 0. Nothing is undefined. I shouldn't say nothing is undefined. The tangent of pi is not undefined. Your answer is 0. Okay? And that's it for today, you guys. So if all that made sense, then you are good to go. If you need to rewatch something, go ahead and do that now, and then start today's assignment, and you guys are good to go.